Hi, this is Mrs. Kidman, and in this video, we're going to be discussing how we can solve quadratic equations using graphing. So solving quadratic equations, what that means is we are essentially setting it equal to 0 or figuring out what the solutions, the roots, or the x-intercepts of a graph are. Now, when we graph a quadratic, because a quadratic has x squared as its highest exponent, what that means is we have options to either have two solutions. We have the option to have just one solution. So we've got two solutions. We've got just one solution. Maybe we have one solution. There we go. One solution. And then we also sometimes have zero solutions. Now, these zero solutions, really, we're talking about in the real numbers. We will have solutions, but they're typically imaginary. So two solutions, what this looks like is when I graph it, my parabola is going to cross our x-axis or have two x-intercepts. If it has one solution, it's only going to cross our parabola or our x-axis in one place, so it has one x-intercept, and zero solutions typically will look something like this, where it never crosses that x-axis. It doesn't mean that the parabola does not exist. It means that it doesn't cross our x-axis anywhere. So the way that we're going to follow through these steps is first we're going to follow these three steps. Step number one is to write the equation in standard form. So that's setting it equal to 0 and moving everything to one side. You can kind of move it to whichever side you want, but that's the way we want to do it. Then we're going to graph the related function. Now, when we graph this in our class, we are going to be using Desmos to graph it as well as in this video. You can use a graphing calculator. You can use another online graphing application. I personally like Desmos, so that's the way we're going to do it in our class. Then the last thing is we are going to find the x-intercepts. That's what I like about Desmos is they actually tell you where those x-intercepts are. So we're going to find our x-intercepts if there are any, and the solutions right here are going to be those x-intercepts. Now we also call those solutions roots. So if something ever asks you to find the roots of an equation, we're talking about their x-intercepts. So before we even get to graphing, let's start by taking a look at this graph here. So here's our graph. We've got the equation f of x equals x, I think this is supposed to say negative x squared plus 2x plus 3, and it's shown below. We want to find the zeros. So remember the zeros, that's also the same thing as the roots or the solutions. The other name for that we know the most is the x-intercepts. So really what this question is asking us, those are four different ways to ask where does it cross the x-axis. So in this case, let's take a look. It crosses right here and it crosses right here. Now these two places or our solutions are when x equals -1 and when x equals 3. Now we can write it like this. Do not put it in parentheses. If you put it in parentheses, then that's a point, and it is not a point. Don't do that. X is -1, and it's when x is 3. Okay, so we can either write it with all of this. We could write x equals -1, x equals 3. Some of us are really lazy in math, so we just leave out this second x equals, and we write x equals -1, 3. But again, do not put it in parentheses. Okay, now let's take a look at this next one. Now, sometimes they're going to be pretty. To be honest, most of the time, unfortunately, our graph is not going to be pretty. So in this case, they gave us our x-intercepts, and we want to approximate it. So we can approximate it, and I'm going to say, okay, these zeros, remember those are our x-intercepts, or the roots, or the solutions. Those zeros are where it crosses our x-axis. So where that is, well, this one looks like it's between, so this is -1, this is -3. It's between -1 and 0, and it's closer to 0. So I'm going to say maybe it's 0.2. We don't have to be exact. We're just approximating, right? And then my other one is between -3 and -4. So I'm going to say it's -3 it's real close to 4, so maybe -3.9. Now, what we're going to do today is we're going to be using Desmos to figure out exactly where those x-intercepts are. We don't need to approximate if we have a resource like that. So what we're going to do here is I'm going to drag my screen over, and I'm actually going to graph this over here. I apologize for the small font, but I promise it'll help. So what we are going to do here is we are going to graph this. So I've got x squared plus 4x plus 1. Now look, this function here looks a lot like the one that we have over here. But the beautiful thing about Desmos is I can actually click on my function, and do you see these little gray dots here? It'll approximate exactly where it is. So this one says that it's negative 0.268. We guessed negative 0.2, so we were pretty close. This other one is negative 3.7. Now we were a little bit high on that, but not bad. So Desmos is really cool because it gives us out to the thousandth place on where those roots are. And so that can be really helpful when we're looking for precision in calculations to know more decimal places. For the sake of our class, to the nearest tenth is perfect. So what we're going to do is we are going to practice writing equations in standard form, and then we are going to find the solutions by graphing. So let's take a look at this first one here, and we want to start by writing our equation in standard form. So remember, standard form is ax squared plus bx plus c. So let's rewrite this, and I want it to equal 0. So I want this whole thing to be equal to 0. Well, I've got to get rid of this 3, so I'm going to subtract 3 from both sides. In standard form, it's x squared plus 2x minus 3 equals 0. Perfect. Then step 2 is we want to graph it. So let's graph it in Desmos. X squared plus 2x minus 3. Bam, there it is. And now I can click right onto my function, and as I go over, I can see where those points are, where those zeros are. So in this case, we have a 0 at x equals 1, and we have a 0 at x equals negative 3. So what are the solutions? Well, our solutions here are x equals negative 3 and x equals 1. Fantastic. Okay, so that's how we would do it. Now we're going to do a couple more examples. These are going to be exactly the same as the previous one. So we want to write it in standard form. This first one is already in standard form, so let's just go ahead and graph it. So we've got x squared minus x minus 2. Now I can click on my function here and see where it crosses that x-axis. One of them is at x equals negative 1, and the other one is at x equals 2. Perfect, there are solutions. Now let's look at number 2. Is this in standard form? No. So I've got to change it into standard form by adding 10 to both sides. And then I get x squared plus 7x plus 10 equals 0. Well, let's take a look at this one. What's this going to look like? X squared plus 7x plus 10. Oh, that one comes over here. And our solutions are x equals what? X equals negative 5 and x equals negative 2. So x equals negative 5 and negative 2. Fantastic. Okay, now this next one here. X squared plus x equals 12. This is x squared plus x. I need to move my 12 to the other side. Minus 12 equals 0. So let's take a look at this one. We've got x squared plus x minus 12. Whoa, this one's a little bit bigger than our other ones here. It's still going to give us that same thing. So right here, as I get closer, as I click on my function, it'll highlight those points. One of them is at x equals 3. And the other one is at x equals negative 4. So those are our two solutions there. Now, all of these ones had two solutions. Sometimes we'll run into some that don't have two solutions. So say, for example, we had the function x squared minus 4x plus 4. Notice how this one only crosses our x-axis once. It hits it right here at 2. Now, that one only has a 1 solution there. The solution is 2. Similarly, we can have something like x squared plus 2x plus 1. This one has 1 solution, and this one is at negative 1. Sometimes we'll see things with 0 solutions. An example of something with 0 solutions might be x squared plus 6x minus 3. Or minus 1. No, not minus anything. 6, let's see. What do we got? Plus 1x minus 2 minus plus 1. There we go. That's what we're looking for. X squared plus 1x plus 1. Fantastic. Okay, do you see how this one never crosses our x-axis here? It doesn't matter how wide I make it, it never crosses. It looks like it does, but it comes real close. But it never actually ends up crossing here. That's because this one has no real solutions. So that's so interesting. Do you remember when we took like the square root of something and it had no real solutions? Our quadratics can also have no real solutions. And it's super cool. So again, when we are solving by graphing, we're going to follow 3 steps here. We are going to write the equation in standard form. Then we're going to graph it in Desmos. And then we're going to find the x-intercepts if there are any. If there's 2 solutions, you'll see them. If there's 1 solution, it'll only hit the x-axis once, and it's going to be at that vertex. If there are no solutions, it's not even going to come close to it. And that is how we solve quadratic equations by graphing.